we're live. Alrighty. Like I said, just prefacing again, it's interior and exterior angles, some notes. First set of notes in Unit 5, quadrilaterals. Interior angle sum. This is dealing with, on the front, we're talking about interior angles. And y'all should know what the word interior means. Whenever you hear interior, think inside. The sum of the degrees of any polygon can be determined by the number of triangles that can be drawn within a polygon. Complete the table below and look at the pattern. Find the sum of the degrees of any polygon. I'll tell you, for this, we will need calculators. You can use your phone for right now, that's fine. Don't let your phone be a distraction, though. If it becomes a distraction, put that down and come get one of my little rinky-dink calculators out the bucket. Alright. First polygon, everybody should recognize. First polygon is a triangle. Like I said, that's the main one we've been working with. That's the main one we're going to work with. Triangle has 3 sides. From any one vertex, I can make, well, one triangle. No, I'll show you what they're talking about. What's the sum of the interior angles of a triangle? Everybody should know that. 180 degrees, right? Let me zoom out a little bit and move this little thingy. Alright. Next figure is a quadrilateral. You may see it as a rectangle. That might be the most specific definition, but this figure is a quadrilateral figure, a polygon with 4 sides. Quadrilateral. Once again, that is the name of this unit. This figure has 4 sides. And the next question says number of triangles. And they're talking about from one vertex, how many triangles. Like a vertex is, y'all should know where 2 sides meet. From one vertex drawn, how many triangles can I create? They're showing you from that one vertex, I can split right here and I can create 2 triangles. If that's the case, if I can create 2 triangles inside of a quadrilateral, what is the degrees of the interior angles of a quadrilateral? 360. The next one, y'all should recognize this shape too. Shouldn't get that hard yet. Pentagon. I'm sure we all know a pentagon has 5 sides. We're showing you once again from any one vertex of a pentagon, using diagonals, I can create 3 triangles inside of that pentagon. If that's the case, if I can create 3 triangles, what is the sum of the interior angles of a pentagon? 540 degrees. If people don't know what we're doing, all we're doing is taking 180, times it by the number of triangles we can create. Next one, hexagon. Hexagon has 6 sides. They're showing you here how many triangles can I create inside of a hexagon? 4. If that's the case, what's the degrees? 720. Oh, and let me show y'all down here what I'm doing. 2 times 180. 3 times 180. 4 times 180. Next one. They didn't show you the shape, but at this point you should figure out the pattern recognition. Next one is a heptagon. Heptagon has 7 sides. Looking at the pattern of how this is formed, if it got 7 sides, how many triangles do you think it's gonna have? 5. 860. Say it again. What y'all got? 900. Next one. Sure y'all recognize this shape. Octagon. 8 sides. 6 triangles. 1080 or 1080. Yeah. Next one, nonagon. 9. 7 triangles can be created. 7 times 180, 1260. Next one, decagon. 10 sides, 8 triangles, 1440. Now, when you get past 10, I think they got names all the way up to like 14. After that, we don't name the polygons anymore. There might be names we don't name them. I can't remember. I ain't never looked, honestly. But after a certain point, instead of calling it by a certain name, the ones y'all recognize, the ones we just did, they just start putting a number in front. Like, say if you got a polygon that's got 18 sides on it. And we don't have a name for that, so we just call it 18 gon. They literally just write 18 in front, dash gon. And you just know it's a polygon with 18 sides. And you can still figure out what the degrees of it and stuff like that. But we do have one for 12, though, that I know. Dodecagon. Dodecagon. This is 12. Remember, we just jumped over now. We skipped 11. So this will have 10 triangles, excuse me. Yeah, 1800. Alright. So that's finding the sum of the interior angles of a triangle. That's if you want to know what all the angles inside will equal. Like, that's me knowing all 3 of these angles add up to 180. That's me knowing all 4 of these angles in here add up to 360. That's me knowing all 5 of these in here add up to 540 together. That's me knowing all 6 of these angles in here add up to 720, and so on. That's the sum of the interior angles. I want to get that clear in y'all mind, because this is what kids mess up every year on this stuff. Y'all never understand when we ask y'all about the sum of the interior angles versus where we ask you about each individual interior angle. So I hope I clear that up this year. I may not. Some of y'all still may be confused, but, well, we're going to try to figure it out. So the formula for that, for what we just did, there is a formula for it. It's a pretty simple formula to understand too. Sum of interior angles, what we just calculated on all those. It says if n represents the number of sides of a polygon, then the sum of the interior angles can be found by using this formula. It's n minus 2 times 180. That's the formula we use to find the sum of interior angles. It's not hard to understand though. We just did it up top here. So the n represents the number of sides. Look at a quadrilateral. We have 4 sides. They're telling you to subtract 2 from that. That's where you get the 2 triangles from. And then times by 180, that's where we get 360. That's all the formula is showing you down here. Same thing for this one. 5 minus 2 will give you 3 triangles. 3 times 180 will give you 540 for the pentagon. For a hexagon, had the number of sides is 6. 6 minus 2 is 4. 4 triangles inside times 180, 720. That's all this formula is saying. Don't let this formula confuse you. It's just showing you what you just did. Since there's a pattern here, you can write a formula based off of it. Y'all okay with that? I hope so. That's not hard to figure out. Alright. Like I say, this is what kids mess up at on this next formula. Interior angle of a regular polygon. A regular polygon is one in which all sides are equal. So if I call a polygon regular, I'm telling you all the sides are equal. So if I call a triangle regular, I'm basically telling you the triangle is an equilateral triangle, that all the sides are the same. If I call a quadrilateral regular, I'm telling you all the sides are the same. That means more than likely it has to be a square, or it could be a rhombus, I guess. Pentagon. If I tell you that's a regular pentagon, anytime I put the word regular in front of something, I'm telling you all the sides are the same. And if that's the case, then your interior angles, especially if it's a regular except for the rhombus, should all be congruent. So regular polygons, when all sides are the same, therefore all angles are equal. To find the measure of each interior angle, I highlighted that word regular last year. Let me highlight it again. Let me not do things like this. Like I said, anytime you hear regular, they're telling you basically equilateral, equal angular polygon. To find the measure of the interior angles of a regular polygon, use this. This is a formula for this. It's just an extension of the formula I gave you up top. It's going to be n minus 2 times 180, but then we're going to divide that by n. N minus 2 times 180 divided by n. We're dividing by n so we can get what each individual angle equals inside. For example, let me let y'all write that down first. This is why I say kids get mixed up. They don't know when to use the one up here and the one right here when we ask them questions. And that's why y'all get stuff wrong all the time with this. And it gets on my nerves because the questions don't even be hard. Y'all just use the wrong formulas. And it's only really 2 to use. The first one and the second one for interior angles. The second one I gave you, use this one they call a figure regular, and they want to know what each individual angle inside equals. For example, for the triangle, even though you already know, if I told you this is a regular triangle or equilateral triangle, most of y'all in here would know that each angle in here will be what degrees? What? 90. Oh boy.
Oh, 60. Oh my goodness.
60 degrees. Most of y'all, that's why I said most, not all. Most of y'all should know every angle in here should be 60 degrees. If you wanted to calculate that, that formula would help you if you didn't know. You would say n minus 2, 3 minus 2, which is 1. 1 times 180 is 180 divided by n, which would have been 3. 180 divided by 3 would have gave you 60. It would tell you what each of those individual angles is. Same thing for the quadrilateral. I can use that same formula. We're going to do it on the back, but I'm just talking about it now. If I want to know what each individual angle of a quadrilateral will equal, even though I already know, say this was a square, and I want to know what each individual angle should equal. You should know already, but if you didn't know, you calculate it. 4 minus 2 would be 2. 2 times 180, 360. 360 divided by n, which is 4, is 90. All these angles, if this is a regular quadrilateral, should be 90 degrees, right angles. That's what you're calculating when you do each individual angle, and so on. Hey, let's do it on the back. We only giving you 2 examples because it's all you really need. I mean, we'll only ever ask you stuff like this, and it's pretty simple. Like I told you though, once you get past a certain number, they don't call a polygon by a name anymore. They just go by whatever number it is and tell you that. So it says find the sum of the interior angles of a 15 gun. Number 1 on the back. Find the sum of the interior angles. Sum. That means they want to know what all the angles equal together. On this, n minus 2 times 180. 15 minus 2 times 180. Yeah, they give me that number, I don't know. Oh, I do know. I guess I'll just wait. Thank you, sir. On this one, they want to know the sum. Tell them what all the angles inside equal. 2,304. That's what all the angles should add up to on a 15 gun. Number 2. What is the measure of each interior angle on a regular 18 gun? This is why I can say where kids mess up. A lot of my kids last year and years before are going to do the same thing they did on this problem, which is wrong. On this one, they say they want to know the measure of each interior angle of a regular 18 gun. So I got to take that step further. I need to divide by n at the end, because I want to know what each individual angle is going to equal. If this is going to be a regular polygon, meaning all the sides and all the angles are congruent. I keep saying it because I wanted to stick in some of y'all, well, most of y'all head. Those who ain't paying attention to me not going to know anyway. This one, I'm using the second formula. N minus 2 times 180 divided by n. So 18 minus 2 times 180 divided by 18. $160 degrees. So each little small angle in the 18 gun would be 160 degrees if it's a regular 18 gun, which they called it. So that's interior angles. It won't get much harder than that. Only thing is, since we feel like you should know how to find the sum of interior angles now, we're going to make you write equations based off that. And most of y'all should be able to figure out how to write the equations to solve. We'll see when we get to the next page. Just remember those 2 things about interior angles: when to find the sum and when to find each individual one. Alright. Moving on. Exterior angle sum. This is dealing with exterior angles. Exterior angles are easy to remember. There's only one formula you have to remember for that. Ms. Welch, pick your head up again and that mask better be on. Why not keep having to speak to you? Exterior angles are always supplementary. That's key. What's supplementary mean? I'm asking.
It adds up to 180.
Yeah, they add up to 180. They're supplementary with that with their adjacent interior angle. So exterior angles are always supplementary to the adjacent interior angle that's next to them. And then it says, on the polygons below, find the measure of each exterior angle, along with the sum of all the exterior angles. Alright. We can do that together. I'm going to zoom in on each one of these. So for a triangle, they want us to find each missing exterior angle, and then they want us to find the sum of the exterior angles. So the first one I need to find is this one next to 61. What's the measure of that exterior angle? You got it already, just saving on?
139.
One who?
139. I mean, oh my goodness.
I said, nah, calculate that again. I'll calculate one more time. I know what it is, that ain't it. 119. This angle right here is 119 degrees. Y'all should know what we did. I mean, if y'all need me to show you the math, 180 minus 61. That's easy to do. Do the next one up here, the one next to 79. What's that exterior angle? 101. And then the one down here at the bottom would be 140. The next thing they ask you is, what is the sum of the exterior angles? Add those together, give me the sum of the exterior angles. Thank you, sir. So you got 360 degrees. So triangle, the exterior angles equal 360 degrees. Go to the quadrilateral next. Start with the angle next to 71. 109. We can do 124 next. $56. 76. 104. And then the last one. 91. Add those together. $360 degrees. Sum of the exterior angles on a quadrilateral, 360 degrees. Pentagon next. Purple. Where's my purple one at? Oh, there he is. We got 130, so that's what, 50? I added those up, yep. What you got? 360 again. Exterior angles on a pentagon, 360 degrees. Should be recognizing a pattern by now. Before we add the hexagon up, what you think the exterior angles about 360 degrees? I'm showing you that we did that for a reason. I want you to understand exterior angles. Okay. No matter what with exterior angles, your sum is always going to be 360 degrees with the exterior angles. That being the case, anytime they start talking about exterior angles, that's the number you should think of. 360. Every single time. Anytime you hear exterior, you should think 360. Don't do that for interior, just for exterior. $68. and 360 degrees. Oh, I don't know what I just wrote. Alright, so real quick on exterior angles, practice. Says, what is the measure of each exterior angle in a regular hexagon? So I call it a regular hexagon, so all the interior angles are the same. They just want to know what's the measure of each exterior angle on a regular hexagon. Hexagon has how many sides? Can't remember. 6. If I want to find out what each exterior angle equals, I'm going to take that 6 and do what with it?
Divide 180.
No, what? No. Nope.
Divide
You confused.
180 by 6.
What?
Divide 180 by 6.
Where you getting 180 from? See, I don't listen to nothing I say. I just said exterior angles, right? What should we always think of with exterior angles? 360 degrees. Boy, boy, boy. I just said it. I know. I just did a whole little thing up there. That went over y'all head, I see. Y'all telling me n minus 2, which ain't got nothing to do with that, then 180. 360 divided by 6, what? 60 degrees. Alright. And then number 4, it says if the exterior angle of a regular polygon measures 12 degrees, how many sides does a polygon have? So, huh? You gotta tell me how you did that.
I took 360 and divided it by 12.
True. Yeah. Honestly, it's the same thing. Even working backwards on this one, because on this one, they tell you the degrees of the exterior angles. They want to know how many sides it has. It's the same process, just working backwards. So you would do 360 divided by 12 degrees. That will tell you the number of sides, which is, well, n equals 30. Yeah. Oh, last thing. Given a regular polygon, given a regular polygon on the coordinate grid, which transformation will place the figure back onto itself? Select all that apply. So, mixing in a little transformations with you already know. The question is, which of these transformations would put this figure back onto itself? By either, you see options over here, you got reflections and you got some rotations. On this, and this is something I'm about to show you right now. To check and see what rotations would work for this figure, you want to get, and we're doing this down here because it deals with exterior angles. To figure out this figure's rotational symmetry, or how I can rotate this figure and land it on itself, I want to count the number of sides, and I want to get basically how many degrees I can rotate this figure and make it land on itself. Let me show you what I'm saying. So, yeah, this figure has 6 sides over here. A full rotation is what? How many degrees? No, a full rotation. 360, right? So 360 divided by 6. That'll tell me every turn I can do in this figure and make it land on itself. So 360 divided by 6, we already did it up there, which is 60 degrees. But I know I could do a 60-degree turn and let this figure land on itself. If I spin it from the center, spin it 60 degrees, it'll land on itself. If I spin it 120 degrees, it'll land on itself. I'm just doubling up. What's the next rotation I could do? Y'all don't get it. Okay, 180. Every 60 degrees, I should be able to spin this figure onto itself. 60, 120, 180, 240, 300, and 360. It's got 6 sides. There should be 6 spins I could do. I just labeled all 6 of them for you. 60, 120, 180, 240, 300, 360. That's easy for y'all to calculate too in your head. You need to do that so you can go over to your side and look at what your choices are and see what choices you can check. Me doing that, I can see for my rotations, I know I can do a 60-degree rotation and let this figure land on itself. Can I do a 122-degree rotation? No. So don't check that. The other 2 things you need to check and see what reflections you can do. They said reflection over the y-axis. You said what now? You can do the y-axis reflection. This is the y-axis right here. I agree with Billy. This is my y-axis right here. I can reflect this image over the y-axis and it'll land on itself. I'm going to check that. The other one they asked you about is the y equals x reflection. Y'all remember what that reflection looks like? That's the diagonal, right? Good. Some of y'all still remember transformations. Good. Oh, I'm going to draw my diagonal line in and see what it look like and see if I can flip over that. Got to line up on it. Oh, there you go. I feel weird down here. I think I got it now. Oh, there it is. My bad. Alright, that's my diagonal line at y equals x. Can I flip this image over that? No, you can't. You can't flip this image over that and it's going to land in the same spot. You can see by that first point right here, this point is going to end up right here when you flip over. That's going to throw the whole thing off anyway right now. So, I can't do the y equals x reflection. Can't do 122 rotation, but I can do the first and last thing. You would have to check that. You're going to see this problem again in your practice. That's telling you right there, and it's the last problem on our notes. I guarantee you're going to see this problem on your test. By the time you get to the test, you're going to be on seeing the problem about 4 or 5 times. So the expectation is that you know how to do that problem by then. How to check for rotational symmetry and reflective symmetry. Oh, I need one of these. Right here. Practice page. Y'all gonna do the practice today too. I don't want you to go to the home learning before you do the practice. I want to see your practice before you leave. So I'm gonna do some of the problems on here, and you're gonna be responsible for the other ones. Real quick on the practice page up top, there is a formulas review. It's a review of the formulas I gave you, or the stuff I gave you really. And I'm gonna do them real quick. So first thing, sum of interior angles in a polygon. You want to find that. That's n minus 2 times 180. Second thing is interior angle of a regular polygon. That's if you want to find each individual one. That's n minus 2 times 180 divided by n. Next one is the sum of exterior angles of a polygon. For exterior angles, the sum of all exterior angles is going to be 360 degrees. Exterior angle of a regular polygon, of a regular polygon. If you want to find each individual, then you're doing 360 divided by n, the number of sides. Yeah. And it says number of sides of a regular polygon. This one you're gonna do 360 divided by your angles, or angle, I guess. I guess I put the angle symbol there. Alright. There's a couple I need to show you on here. I'm gonna ask y'all to help me set up something, but number 4, just because I know kids usually have trouble with this, so I'm gonna give you an example of this because you haven't seen this exact one. Most kids are able to figure it out, but some kids be tripping. Number 4, it says the sum of the interior angles of a polygon is 1,620. How many sides does this polygon have? My bad, I should have went down here. I'm sorry. So I'm looking at number 4. I'm looking at number 4 because you haven't seen the question asked this way yet. So I'm going to help you on this one. The sum of the interior angles of a polygon is 1,620 degrees. How many sides does that polygon have? This is a problem where you have to work backward. They already give you the sum, and they want to know how many sides does the figure have. I would use the formula, and I would write an equation. I don't know what you would do. What you did? You got your hand up. Why do what I got to do? What you did?
I was just asking, did you divide it by 180?
That's not all you got to do. That's why you need to use the formula on this one. So this is one calling for sum. They told you the sum already, but you can still use the formula for sum of interior angles. This is sum of interior angles right here. Read the problems. I'm looking up here at the top. My sum of interior angles formula is that first one. N minus 2 times 180. I'm going to set that equal to what they gave me the sum of as 620. They told me the sum. I just need to work backwards and solve. Working backwards, you're still solving an equation. Only thing is, some of y'all might get confused because this equation is a little different. On this equation, what's the first thing I need to do? Nope. Can't. Nope. I wouldn't. You can distribute, but I wouldn't do that. That's a waste of time. Divide by 180. Thank you. You got to do the division first because it's outside of this parentheses right here. Remember, when you're solving an equation, you're doing backwards of PEMDAS. So I would say the parentheses for last. I would do this multiplication of division first. Get that off. Divide by 180. Divide by 180. What's that? Oh, 9. Thank you, bud. Sorry, I didn't hear you. So now I got n minus 2 equals 9. Now did you see when I brought my n minus 2 down now? I just dropped the parentheses because I don't need it no more because I took the 180 off the end of it. So now it's n minus 2 equals 9. What I need to do next? Plus 2. Why would you subtract 2? Plus 2. This is what people usually forget if they don't write the equation out. You see how Jasavion, he wasn't quite wrong. He said he was going to divide by 180, but most kids forget to add the 2 back in at the end if you're going to do that. So the number of sides is 11. Because since you subtracted 2 in the original formula, when you go in the reverse, you got to add the 2 back. Alright. Like I said, that's just one you haven't seen from me yet, so I want to show you that. Number 5, real quick. Y'all should know how to do these too, but kids surprise you. On this, they want us to solve, 5 through 10. Want us to solve for the indicated angle or measure. In this case, they want us to solve for this angle with x on it. That's cool, I can do that. But first, I need to figure out an equation I can write to solve for that. To figure out that equation, I need to figure what kind of figure this is, and I need to figure out what the figure itself adds up to. How many sides does this figure have? Anybody count it yet? Huh? Somebody said 7 sides. I agree. It has 7 sides. That's the case. If it has 7 sides, it has 5 triangles in it, n minus 2. So it's 5 times 180. 5 times 180 is what? 900. So the total degrees of this figure is 900 degrees. If that's the case, I'm sure y'all know I can solve for x now. We need to write the equation to solve for x. Now, if you don't want to write the whole equation out, if it's just numbers like this, I'll let you get away with just adding them all together right here. So my equation would be this plus this plus this plus this plus this plus this plus x equals 900. Thing y'all don't need to forget though, and some of y'all need to write it in for yourself because y'all will leave it out. What degrees is this right here? Mostly, a lot of y'all gonna leave that out when that should be included. 90 degrees. If you add all these other degrees you have up, you should get 806 plus x equals 900. Subtract 806. Who? Oh, I thought somebody said 74. I was like, what? X equals 94. That's what needs to be done, though. Number 6. You want to find x on that one. All I want to know is what's the sum that you're using. What does this figure add up to? What? Stop saying stuff. Just say, man, think, bro. 360. 2 times 180. It's 360 degrees. Alright, then from there y'all can find x on that one. Y'all don't need me. I just showed you how to do it on number 5. Let me see if there's another one I need to do. I'm trying to speed through because I don't feel like doing all these problems. Of course, it gets a little bit hard on the back, but it should. Number 7. I'm gonna do this one because kids always get stuck on this one. Before I do it, anybody look at number 7 for a second. Anybody got an idea how to solve for x on this one? I thought you might come up with something. Mm-hmm.
So there's 9 sides.
Okay. Yeah, it's not 9 sides. No.
Oh, 10 sides.
Okay.
So there's 10 sides.
Mm-hmm.
This is probably wrong.
Talk to me.
So you do 10 minus 2 is 8.
Mm-hmm.
Multiply that by the 180.
Mm-hmm.
And you get 1440.
Okay.
And then these are all, like, they're all congruent.
Mm-hmm.
So they all equal 10x plus 4.
Mm-hmm.
If you do 10x plus 4 multiplied by 10 equals 8.
That, you would not be wrong doing that, but that is a long way of doing this. You were almost there. Thought you were gonna figure this out. So you figured out that they all equal 10x plus 4, right? All those angles. You knew that why? Because they marked what all those sides congruent, right? So if all those angles equal 10x plus 4, all those angles are congruent, yes? You can't just find one of those angles?
Oh, yeah.
So you want to try again?
So 10x plus 4
It equals what?
Oh, not 1440.
No, girl. You was almost there. You lost yourself at the end. I agree with you up to this point. So I would have did this, mama. I would have said 10 minus 2 times 180. That's what you said. But I would have took this step after. I would have divided by 10. You got 1440, right? When I divide by 10, I'm going to get 144. Because there's 10 angles in here, aren't there? Aren't they all congruent? So if the whole thing equals 1440, that means all these individual angles equal 144, 144, 144, 144, all the way around. Even my angle with my expression on it. If that's the case, my equation to solve for my expression is going to be 10x plus 4 equals 144. That's much simpler than multiplying by 2 and doing what you did. But you wouldn't be wrong if you did that, Ronald. Just be a little bit bigger of an equation starting out. Mm-hmm. Number 8. Let me just talk about setup. I'm not about to do this one with you either. Number 8, expressions. So obviously you got to write this out for yourself so you can combine like terms and stuff like that. Some of y'all gonna try to combine them without writing it out. That's fine. But this is why kids mess up a lot at trying to do it all combined in here and then write it down here. It's up to you however you want to pull it off. But the main thing you need to get is the sum. Before I can write an equation to solve for x on number 8, I need the sum of these interior angles, which is what? How many sides does it have? Let's start there. 6 sides. So that's 6 sides, 4 triangles, times 180, or n minus, that's that n minus 2 part. I don't really write it, but I hope y'all understand it. Subtract 2, get 4. 4 times 180 is 720. Sum of the interior angles is 720. So, for those who need to write the long equation out, is this plus this plus this plus this plus this plus this equals 720. Combine like terms, then solve. I'm not doing that for you because you're capable of doing that yourself. You got 6 sides, you got 6 angles. Make sure you got 6 things added together equaling 720. That's all interior stuff. Look at number 9 real quick. Number 9. These are all exterior angles. They want us to solve for x. Billy, I ask you again, these are exterior angles. So what I'm going to set these angles equal to?
360.
I'm going to set these equal to 360. There's no calculation I need to do. Anytime you see exterior angles, understand they add up to 360. Set those all equal to 360, solve for x. Last one, I promise you. But, oh yeah, this is another test question. That one I showed you on your notes, test question. This one I'm showing you right here is a test question too. For definite, for sure, I know. I always have a couple kids that can figure this out though, but I don't know. We'll see about y'all in here. The figure below represents an octagon shaped pool deck built around it. The connection between each vertex are angle bisectors. So they're saying these little connections right here, here, are all angle bisectors. Y'all should know what an angle bisector is. It says, what is the measure in degrees of the angle marked with an X? So this is an octagon shaped pool right here. I'll tell you, this figure is regular, meaning all the sides and angles are congruent. Anybody got an idea how you find the value of X? Oh, Billy, let's go. I'm I'm listening, Billy. You gonna tell me something?
No, I got it. That's all.
Anybody? How do I find the value of X?
Because it was a regular option.
It is. I didn't directly tell you that, but I'm telling you that it's a regular. Nobody? Nothing? Zach? No? Hmm?
Wait 2 seconds.
Okay.
Yeah, never mind.
At least you'd be trying. You got what? You're just not there yet. You're not wrong. Tell me how you got there. That'll at least help us get where we're going.
It's in half, so it's 67 points.
Oh, now you know. You let him get you to there, and now you ready to take over. Yes. So, exactly. So, I'm going to let you take it, Jeremiah, because you got us there, and she tried to take your thunder. Yeah. Go ahead, Jeremiah. Take us there, man. What you did to get what you got. And we'll do the... Like he said, it's 8 sides, so I put an 8 over there already for you. Go ahead, talk to me.
I put 8. Oh my God, I'm saying.
I got you. Go ahead.
8 minus 2.
8 minus 2
Times 1.
times 180
Divided by 8.
divided by 8. He's doing that formula to find each individual angle. N minus 2 times 180 divided by N. So he's finding each individual angle on here. Go ahead. What's that? Just give me this number right here. No, man.
Oh,
No.
wait.
When you divide it by the 8.
Oh,
135, right? Let's stop right there for a second, Jeremiah. Let's show them. So, by knowing that, now I know that all of these angles right here is 135 degrees, 135 degrees, 135 degrees. Some people got to this point. Sound like y'all did. Billy got here. She got confused after she got to this point. Then Jeremiah kind of guided her to the rest of the way. All those angles that I'm showing you are 135, even the one that I didn't mark over here, but this big angle right here is 135 as well. But they asked you for angle X, and they told you, what about the vertexes on Jeremiah? The connections, what did they say they were? Angle bisectors, right? You know, angle bisector splits an angle how? In half. So you did what to 135? Divided that by 2. And then for X you got what? I swear to you guys, this is a test question. Not hard. You just need to see it. Huh?
It's a visual thing.
It is. But this is a test question. Alright, I'm done what I had to do. Finish that practice page, then do the home learning. What? I'm gonna post the home learning. I have one for this performance matter.
Are you gonna put the practice up for
No. I still want you to do it because I want you to have the practice. You need to practice as many. I think honestly we should do, and I should have proposed this over the break. Hold on, let me turn this off. I don't want to say all this on camera.